Okay, hello, Makoto and Bill. I'm contacting you to ask you for some help. On Wednesday, I am going out to Staten Island to meet with Hannah at their school, and she would like me to observe to see what they're doing, and then have some ideas for what they can do to help implement primary math. They do it K to 3, and it's basically one teacher teaches all of them. But what she would also like me to do that day is to do the part of the workshop which their teachers had to leave the day that they were there for the division. Now, what I did was I put together this, excuse me, I put together this little screen here to help you see how I see division done, and then I'll take all of your input on what you think. But from a basic progression and methodology, it starts out you have to get kids to understand the concept of division, both partitive and quotative. Then you have to do two-digit divided by single digit that has no remainder, two-digit divided by single digit with a remainder. Then get into the three-digit by one digit, three-digit by two-digit, and then finally larger examples. Now, when I look back, let me pop up the PowerPoint that Bill used the day I was there. It gets into division it does that concept of division, dividing things up, partitive and quotative, and going through that. My first question is, I realize this was a teacher workshop and it's important for them to understand the partitive, quotative. I'm not sure exactly when you're doing it with kids, how much you get into that. So that would be my first question. Maybe I'll keep a list of how many questions I'm asking you. Question number one is, as far as partitive quotative goes, is it that we do examples that show both? Do we use the terminology? I'm assuming that we don't, but please answer that question. And then do we focus on them knowing which type it is, or just can they conceptually understand? Moving right along, then we get into the quotative, partitive quotative. Let me keep going. Now, the next thing it did was it went into division with remainders. And it did it through, again, as you look here, we're still pretty conceptual. Like we're not using the algorithm as far as like, the division bars that we normally use. So I'm not sure when that gets introduced. Again, another one that has a remainder, that's fine. Talk about how it relates to solving problems. Then the hardest problem that got done here is 72 divided by 3, and then it's basically over. So my question is, going back to the smart file that I made, which is right here. Um, Even starting, like, I understand the concept of division and how to break it down. Again, my first question was how much we get into the partitive quotative. Do the kids know we're doing that, or do we just make sure that our examples have different variations? Um, Next question is, when you're solving the two-digit by one-digit, I'm assuming we're using the traditional algorithm, but it would be really nice for one of you guys to work one out and explain the actual wording that you're using. These are very easy to model with either base 10 blocks or cubes. I've done this many, many times. Same thing, two-digit divided by single digit with remainder. Same thing, very easy to model out for the kids. It's when you go to three-digit by one digit that you're starting to leave, sometimes you're starting to leave the world of, at some point the kids are not going to be using base 10 blocks or something. Very easy to model this out with base 10 blocks, something like 532, 5 flats, 3 rods, 2 units. You're dividing by 4, so you put 1 flat in each one, that's 400. You trade the flat in for 10 rods, and now you have 13 rods, and you divvy those up. I got no problem showing that if that's how Singapore wants it done. Then moving along, though, where it starts to become, that is where it's kind of good to do both concrete and or partially concrete, and show it with models. But then at some point we're rolling into actually just solving them with the numbers. I was wondering how long you stay at the stage where you actually model them out, and then how long until you move into the ones where you're just doing it basically algorithmically, but in their head they're picturing the things. But it's when you get down to this 542 divided by 32, that is very challenging to act out as a model. And I would be very interested to see how you transition that. I know if I were in a workshop, I would have my hand up the whole time wondering how you're going to do that one, because how to do all the other ones are very easy up to this point. It's what's our specific methodology. Now, personally, what I've been teaching for the last few years is partial quotients division. And I even have some really cool, helpful hints on how to do partial quotients, but I'm not positive if, nothing is addressed in our PowerPoint as to how the kids in Singapore solve problems like this. And same thing, some teacher is always going to ask, like this bottom example, 43,543 divided by 287. They want to know, well, how are kids ever able to solve something like that using our technique? And as a person who teaches partial quotients division, that is where it gets a little more interesting on the example. So I don't know if I use the smart recorder to make this video for you. I don't know if you want to make a video. I would be more than happy if someone wants to call me on the phone, work out the problems. I could write down exactly what you're saying. That's fine with me too. But I just want to make sure that I'm staying in line with how you guys envision that this is being shown. So I'm gonna put this on my YouTube channel and I'll email it along to you guys. And then if you could take a look and let me know, I would greatly appreciate it. Thanks so much. And oh, and thanks so much for the dinner at Shanghai. That was really nice. I definitely enjoyed that. And I look forward to hearing from you. Thank you.